The show that reveals how extraordinary items in our world are designed, constructed and produced. See the engineering, the technology and big ideas that make the world go round. Find out how it works. Coming up, how grand pianos are built, by hand from the pedals up. Why the humble tap never lets you down. Some serious engineering makes sure the water flows perfectly. And next time you buy a takeaway, think about how this unappetizing mash is transformed into millions of bottles of soy sauce. But first, wine glasses. It's not just the grape or vineyard which affect the flavor of a great wine. The glass makes a difference too. This factory makes 250,000 of them every day. But before mass production, you have to start with a prototype. Now, you may not pay much attention to the shape, but each glass is scientifically designed to enhance the flavor of the wine it's intended for. For example, there's a bitter agent in red wine called tannin. This only mellows when it comes into contact with air. So to lose some of the harshness, the glass has to have a wide bowl which can let the wine breathe. You should only pour 1/3 of a glass, and then you'll be able to swirl it around to speed things up. It's the other way round for whites. They have subtle aromas which are important to the flavor. These aromas drift away when they make contact with the air. So you need a small, narrow glass to keep the aromas where they belong. A 3D image is modeled on a computer, and then a prototype is made by hand. The blower's got to keep the pipe moving, or the white-hot semi-fluid substance would drop to the floor. The oak mold has been made to the glass designer's exact specifications. The glass is blown in and sets in about 15 seconds. They warm up the bottom of the bowl and then add another blob of glass. That's cut, stretched, and then turned to make the stem. They add a final blob and then press it into a mold to make the base. The prototype is a success, and the design is ready to go into mass production. Over at the factory, handmade processes give way to a high-tech production line. The main ingredient of this glass is quartz sand, which accounts for about 70% of the mix. They drop in some soda to lower the glass's melting point, lime helps to stabilize the compound, and aluminium and titanium make the glass tougher. The mix is lifted up to the melting furnace, where it's joined by pieces of glass that the factory recycle from waste in seconds. At 1500 degrees Celsius, the materials melt and fuse. At this temperature, glass has the consistency of warm chewing gum. 36 hours later, it's carried away in heated tubes, and then squeezed through an opening and cut into portions of 240 grams. The glass is still white hot, about 1200 degrees Celsius. The portions are squashed flat, and then a stream of air from above the center forces them into roughly the right shape for a wine glass bowl. The exact shape of the design is created as it's enclosed in a water-cooled mold. After 5 seconds, the mold opens. The glass has cooled down to 400 degrees, but it's still extremely fragile. Each glass has a temporary lid on top of its bowl which is used to carry it around the factory without getting damaged. The bowl is turned upside down and the bottom is heated with a torch. Then they get their stems and bases. Another blast of fire shapes and polishes the bases. After their baptism of fire, the glasses are given an hour to cool off. A laser lops off the temporary lids. These go off to be melted and start the process again. The sharp edges are smoothed with sandpaper, but are still too rough to be drunk from. The rims are then reheated to 1200 degrees Celsius and get smoothed out in just a few seconds, smooth enough to be touched by lips. After a last check for air bubbles and cracks, the wine glasses are ready to be safely packed and shipped. In this factory, they've turned a traditional craft into a modern production process. It's big, it's beautiful, it's a grand piano. And each one of these majestic instruments is exquisitely handcrafted. The main difference from a standard upright piano is that in a grand the strings are longer and have to be arranged horizontally. The sound is produced by a felt hammer hitting up to 3 strings at once. The thicker and longer the strings are, the lower the note. Each string begins life as a single steel wire attached to a spinning machine. One of the workers scuffs up the surface with sandpaper, so when a copper wire is wrapped around, it'll stay in place. He adds another wire to the string to give it a deeper bass note. The strings for a grand piano range in length from just 5 centimeters to over 2 meters. That's what allows them to produce an incredibly wide range of notes. Finally, he tightens the end of the wire to stop it from uncoiling. They have to use layers of flexible wood for the piano's casing, so they'll be able to bend it into the traditional shape. They're glued together and then squashed in a press until the adhesives dry. Then it's taken over to another press, which will give it its shape. It's a tough job to get it into position and requires a bit of muscle and a lot of teamwork. When the strings are fixed, they'll have a combined tension of 24 tons. so the metal frame needs to be a super tough structure. It's made of precision cast iron in a technique that was developed in the early 19th century. A cocktail of bronze powder, dissolver, and thickener is sprayed onto the metal surface to fill any pores and give the frame a smooth finish. The metal frame weighs about 170 kilograms and has to be lifted into the wooden casing with a pulley. Then it's time to fix the strings, all 240 of them. Low notes have just got one string, but the middle and higher notes have 2 or 3 to make them louder. They're called bichords and trichords. Each individual string has to be stressed until it reaches the exact pitch. Finally, they check the strings with a felt hammer. The hammer's controlled by a mechanism that enables a series of notes to be played consecutively at high speed. The workings of the piano are now complete, but before it can be fitted into the casing, an expert must check that all the hammers reach the same keystroke height so they produce an even sound. A key has to drop under a weight of 52 grams, and they all have to be tested one by one. Who said the music industry was glamorous? All that remains is the final assembly. Every individual grand piano is handcrafted to the highest standards. That's why this factory builds, on average, just one a day. Coming up after the break, the mass production of a tap, molded, cut, and then approved by a robot and a computer, all so you can wash your hands in a steady flow. And the science behind soy sauce, how microbiology combines with traditional methods to make the distinctive flavor. Some objects are so familiar to us that we never actually consider how they are made or how they work. A single lever mixer tap begins life as a bucket of very fine quartz sand. It's forced into heated molds and then baked at 260 degrees Celsius. When it's hardened, the sand has been transformed into a mold itself. Once they've smoothed off the edges, it can be used to cast the taps. Meanwhile, recycled brass parts have been melted into a huge 2.5-ton furnace at 1050 degrees Celsius. They place the molds into a low-pressure casting machine and blow away any loose grains with an air gun. As the liquid brass is poured in, the duct is heated with a blowtorch to keep it flowing smoothly. 2 minutes later, a couple of pairs of taps drop out. They need to get rid of the solid sand inside the taps, so they blast them with ultrasonic sound waves to break it down into grains. The taps have been created as co-joined twins, but they are easily separated by a metal saw. Each tap can now be drilled, countersunk and cut. This large machine contains 17 different tools and does all of the jobs single-handedly. Each opening and thread is carefully checked. If any of the taps aren't up to scratch, they get melted down and remolded. For those that pass, it's time to get scrubbed up. First, a robot smooths out any rough edges by rubbing them on sandpaper. Then it polishes the surface with pure cotton. The brass body is finished. Another robot displays every angle to a camera lens, which checks it's perfect. This one is faulty, so it's put to one side for inspection. A human has the final say, and the quality controller confirms the robot's findings. It's rejected and will be recycled. For the lucky survivors, it's time to take a dip. A computerized system guides them on a route through several troughs. First, a rinse removes any dirt or grease. Then they get dunked in nickel. It forms a silvery coating which helps to protect them from corrosion. Finally, they're immersed in a chrome bath for 4 minutes. Beneath the bubbling surface, the taps are receiving a final coating that will help them last a lifetime. An electrical current sets the taps to a negative polarity and the chrome bath to positive. This causes the taps to attract tiny chrome particles from the water and creates a fine surface layer of chrome that's thinner than a human hair. While the bodies are drying, the heart of the mixer tap is put together. The simple mechanism is what makes the tap so efficient and environmentally friendly. Turning the handle moves an element with an oval opening inside the tap. To the left opens the waterway to the hot water pipe, in the center to both hot and cold, and moving it to the right closes the hot water flow so just cold water flows out. Mixer taps with spray mechanisms like this can save up to 80% of the water used by standard pillar taps, as they produce a steadier flow with less water pressure. Once the mechanism is put inside the tap, a final test ensures that the water flows out smoothly. They've been polished by robots, coated with nickel and chrome, and their inner workings will help to conserve the world's water supply. Maybe this humble tap is not so humble after all. Soy sauce is a key ingredient in both Chinese and Japanese food and has become a common sight on British supermarket shelves. In this Japanese factory, they use hundreds of years of brewing experience to produce what the locals call shoyu, but is best known to the rest of us as soy sauce. It's a sauce that begins with very simple ingredients: soybeans, wheat, and a special mold. Master Hiroyama oversees the production process, and the first thing is to make sure that they've got the right mix of ingredients. When they've steamed the beans and milled the wheat, they call the lumpy mix koji. The mold multiplies and produces enzymes, and this kick-starts the fermentation. this room, the koji is kept on the move to make sure it's thoroughly mixed. Sea salt and water are added, and then the moist mash is transported into huge tanks. It's left there to ripen for about 6 months. The sludge doesn't look like anything you'd want to eat at the moment, but at a microscopic level, a transformation is taking place. The mold breaks down the soybean proteins into amino acids. Meanwhile, the wheat ferments and produces sugar, giving the mash a slightly sweet taste. Together, these two processes give soy sauce its characteristic aroma, flavor, and color. Despite its appearance, the master is impressed with the flavor, so the mash can go on to the next step. This stage requires linen, several kilometers of it. The mash is spread evenly on top, and then the linen's folded 600 times to make a massive soy sandwich. A team of workers haul the tower of linen through to a hydraulic press. The press wrings out the linen with a 200-ton weight and squeezes out a brown liquid. Each pile yields around 5,000 liters of raw soy sauce. It's heated at ultra-high temperature, and then the 6-month process is over and they can bottle it up. In sharp contrast to the rest of the production, this is done in just a few seconds. Each year, this factory produces 270 million liters of soy sauce, which will find its way onto the plates and palates of consumers across the planet.